All right, so these are the solutions to the practice question I've given onto us. So just follow through the process with which I sub. Okay, so we have 8 raised to the power of 2x minus 1 equals to 1 over 512. So 8 right away we turn it to 2 raised to the power of 3. We have 2x minus 1 equals to 1 over 512 is 2 raised to the power of 9. All right. So if you have two powers, you multiply. 3 is going to multiply 2x and minus 1. So 3 times 2x is 6x. 3 times minus 1 is minus 3 equals to 1 over 2 raised to the power of 9. And from here, we can have that 2 raised to the power of 6x minus 3 equals, now from this law now, 1 over 2 raised to the power 9 is the same as 2 raised to the power of minus 9. If this 2 raised to the power 9 goes up, it becomes this. So since the bases are equal, we can say 6x minus 3 equals minus 9. And we can have 6x equals to minus 9. If minus 3 comes to the other side, plus 3. So we have 6x equals to minus 6. So we have x equals to minus 6. We divide both sides by 6. And finally, our x equals minus 1. So that's the answer to the first question. Okay, so the number 2 question is what we have here. So we've been asked to find x once again. So the left hand side is pretty much easy. There is nothing to do to it. But for this right hand side, now let me establish something to us. It's going to help us to be fast in solving some questions. So for instance, if you have let's say 1 over a raised to the power of m minus n. Now this thing you have here is also the same as a raised to the power of, if this m should goes up, it becomes minus m, and if this minus n should go up, it becomes plus n. Now, having established that, it also means this 1 over 3 raised to power x minus 2 is the same as 3 if x should go up, minus x if minus 2 should goes up, plus 2. So we can then equate the powers as 3x minus 8 equals to minus x plus 2. So we collect like terms. We have 3x. If minus x comes to the left hand side, it becomes plus x. We have 2 on the right hand side. If minus 8 goes to join it, we have plus 8. So 3x plus x, that's 4x, equals to 2 plus 8, that's 10. And x equals 10 over 4. And x equals 2 can go, that's 5 over 2. 2 in 10 is 5, 2 in 4 is 2. So that's the answer to the number 2 question. Okay, number 3 question. On the left hand side, we have 2 raised to the power of x. Now 0.125 is in decimal, so we want to change it into a fraction. That means we take the decimal 1, 2, 3. And that's going to be 125 over 1. 3 times means 3 zeros. And this is now 2 raised to the power of x. So let's try to divide 125 here, 1. 125 can go perfectly 1000, it will give you 8. So you can use your calculator to confirm that. So we have 1 over 8. And from here, we have 2 raised to the power of x equals to 1 over 2 raised to the power of 3. And we have 2 raised to the power of x. If 2 raised to the power of 3 goes up, it becomes 2 raised to the power of minus 3. And hence, x equals minus 3. That's the answer. All right, so we've been asked to simplify the question we have in front of us. So let me quickly remind us on one of the law of indices. So if you have a raised to the power of m over n, anytime you have a fractional power, the law says that you write a root. This a is going to be inside the root. This denominator n is going to come here, and this numerator m is going to come here. Now, using that as a principle, it means 9 raised to the power 1 over 2. We are going to write 9. This 2 is this square root, square, indicative of 2 raised to the power of 1 times 27 again. You write your root sign, but 3 is the denominator here. You write it here. 27 raised to the power of 2 over 64 raised to the power 2 over 3. The same thing. You put your 3, you put your 2. All right, so from here now, the square root of 9 is 3. Raised to the power of 1 is still 3 times the cube root of 27 is 3 raised to the power of 2. The cube root of 64 is 4 raised to the power of 2. Now this is 3 times 9 over 16. And this will give us 27 over 16. So this is our answer. If you like, you can leave it in a mixed fraction. Okay, so question 5, we've been asked to simplify it. So right away, let's change everything to base 3. This is 3 raised to the power x minus 1 times 9, 3 raised to the power of 2, x plus 1 times 27 is 3 raised to the power of 3 minus x over 81 is 3 raised to the power of 4, 5x minus 3. And from here, we have 3 raised to the power of x minus 1 times 3 raised to the power. If 2 multiplies x and 1, we have 2x plus 2 times 3 raised to the power. If 3 multiplies minus x, we have minus 3x. All divided by 3 raised to the power. If 4 should multiply 5x and minus 3, 4 times 5x is 20x, and as 4 times 3 is 12. Now, if you look at this numerator, base 3, base 3, base 3, so you pick one of the base and you add all the powers. So that's x minus 1 plus 2x plus 2 minus 3x all over 3 raised to the power of 20x minus 12. Now, if you look at this, let's the algebra, that's the guys with x, you add and subtract them, then the numbers should do the same to them. So if you look at it, x plus 2x is going to give you 3x. 3x minus 3x is going to give you 0. That means the guys with x have disappeared. You are left with minus 1 plus 2. Minus 1 plus 2 is going to give you 1. You are owing 1, you have 2, you are going to be having 1. So we have 3 raised to the power of 20x minus 12. So from here, from the principle I've been teaching us, this is the same as 1. If these two guys should go up, they will change in their sign. 20x becomes minus 20x, minus 12 becomes plus 12. So finally, you have 3 raised to the power of 1 plus 12. That's going to give us 13 minus 20x. So that's going to be our answer. All right, so question 6. This is pretty easy. So if we are going to solve this, we have a lot of ways we can solve it. This question is the same as all over 1. If you cross multiply, that means what you have is 5 raised to the power of x minus 3 equals to 125 raised to the power of 3x minus 4. And from here, this is 5 raised to the power of x minus 3 equals to 125 is 5 raised to the power of 3x minus 4. And this is 5 raised to the power of x minus 3 equals, if we multiply 3 times 3x, that's 9x. 3 times minus 4, that's minus 12. So from here, x minus 3 is equals to 9x minus 12. So that's equating the powers. So we have x, if 9x should come to the left hand side, it becomes this. And we have minus 12, if minus 3 should go there, it becomes plus 3. And from here, x minus 9x is going to give us minus 8x. Minus 12 plus 3 is going to give us minus 9. And you divide both sides by minus 8. If you divide perfectly, you get this. X is minus cancel minus 9 over 8. So that is your answer. Okay. Question 7. Now, if you notice question 6, what I did was to cross multiply. Here now I'm going to try another second method. I won't cross multiply, but it's still the same thing. You can always use sometimes for one question about 2, 3 methods. So for this now, I'll just change it right away. 8 is 2 raised to the power of 3. We have 2 minus 3y is 2 raised to the power y plus 2. Don't forget we are looking for y. So this is 1 over 2 raised to the power 3 times 2 is 6 minus 3 times 3y is 9y. 2 raised to the power y plus 2. Now from here now, this over 2, if it goes up, 6 will change to minus 6 and minus 9y will change to plus 9y. If you remember, I told you then, when anything is at the denominator and it is 1 over that thing, if the powers goes up, they change in their sign. This is positive 6, that's changed to negative 6. This is negative 9y, it has changed to positive 9y. And so from here, we can say minus 6 plus 9y is equals to y plus 2. So on the left hand side, we have 9y. If this y on the right hand side joins it, it becomes minus y. Then we have 2. If minus 6 should come to the right hand side, it becomes plus 6. So 9y minus y is 8y. 2 plus 6 is 8. And y equals to 8 over 8, which is equals to 1. Okay, so question 8. They ask us to express the product of these two decimal in standard form. So like I've always explained, the first thing to do is remove the numbers from being a decimal by taking the decimal point outside. So that's 1, 2, 3, 4. So that is 45 times 10 raised to the power of minus 4 times. You do the same thing here. The decimal, take it outside, 1, 2, 3. And that's 25 times 10 raised to the power of minus 3. The next thing to now do is the 45 and the 25, you want to put them in one side, times the 10 raised to the power of minus 4 times 10 raised to the power of minus 3 on another side. Now 45 times 25 is going to give us 1125 times 10 raised to the power minus 4 plus minus 3. Don't forget, when you are multiplying two indices base 10, you pick one and you add the powers. So this is 1125 times, this will eventually give 10 raised to the power minus 4 minus 3. And this is 1125 times 10 raised to the power minus 7. Now 1125 is not in standard form, so you write it in standard form. That's 1, 2, 3. So you have 1.125 times 10 raised to power. Since we move towards the left hand side, is raised to power 3. We move 3 times 10 raised to power minus 7. So we have 1.125 times 10 raised to the power of 3 plus minus 7. And that's going to give us 1.125 times 10 raised to the power of 3 minus 7. And that's 1.125 times 10 raised to the power of minus 4. And that is our answer. All right, so again, question 9. We want to leave our answer in standard form, but like I said, it will be practically impossible to do this because they are in decimal. And don't forget, we want to see the step-by-step working on this question. So we are going to go step by step. So the way to proceed is remove all the decimals, and that's going to make things easier. So if I come outside, if I want to remove the decimal, so right away, just once. So that's 6 times 10 raised to the power minus 1 times 32. No need to remove it since there's no decimal. Times this one, there's a point here, you move 1, 2, 3. So that's 4 times 10 raised to the power minus 3 all over 1.2. You move just once. That's 12 times 10 raised to the power minus 1 times you move 1, 2, 3. That's 8 times 10 raised to the power minus 3 times you move twice 1, 2. That's 16 times 10 raised to the power minus 2. All right, so from here, all the numbers, that is 6 for the numerator times 32 times 4. You can put them all to one side, divided by, for the denominators, we have 12 times 8 times 16 on another side, times, then all the 10 raised to the power. So we have, for the numerator, we have 10 raised to the power minus 1 times we have 10 raised to the power minus 3. All divided by, we have 10 raised to the power minus 1 times 10 raised to the power minus 3 times 10 raised to the power minus 2. All right, so from here, let's see, 4 here, 1, 4 in 16 is 4, 8 here, 1, 8 in 32 is 4, 4 cancel 4. We are left with 6 over 12, 6 here, 1 in 12, 2. So we are left with 1 over 2. Now, this place too, this can cancel this can cancel this. So you are left with 1 over 10 raised to the power of minus 2. 1 over 2 is going to give you 0.5. If you use your calculator to confirm that, times, this will give us 10 raised to the power of, if minus 2 should goes up, it becomes 2. Now 0.5 is not in standard form, so we change it to 5 times 10 raised to the power minus 1 times 10 raised to the power of 2. And finally, we have 5 times 10 raised to the power minus 1 plus 2. And the final answer is 5 times 10 raised to the power of 1. That gives us the final answer. Alright, so again, for this question, the decimal is still the same pattern of question. We want to leave it in standard form. So you move 1, 2, 3, 4. So that's 3, 2, 4 times 10 raised to the power minus 4 times you move 1, 2, 3, 4. That's 64 times 10 raised to the power minus 4. The decimal is here, 1, 2, 3. That's 48 times 10 raised to the power minus 3. Times you move twice, 1, 2. That's 12 times 10 raised to the power minus 2. So from here, we have 324 times 64 all over. That's the numerator, the numbers, and the denominator is 48 times 12, all in one bracket. Then the 10 raised to the power of minus 4 times 10 raised to the power of minus 4 all over. We have 10 raised to the power of minus 3 times 10 raised to the power of minus 2. Now from here, 12 here, 1. 12 can go perfectly in 3, 2, 4. That's going to give us 27. Now for 64, so okay, 2 here is 24, 2 here, that's 32. What can go again? 8 can go in 32, that's 4. 8 in 24, that's 3. 3 here in 27, that's 9. So that means we are left with 9 and 4. So 9 times 4 will give us 36 times. We have 10 raised to the power of minus 4 plus minus 4 over 10 raised to the power of minus 3 plus minus 2. And it becomes 36 times. 10 raised to the power of minus 4 minus 4, because plus times minus is minus, and 10 raised to the power minus 3 plus times minus again is this. So we have 36 times 10 raised to the power of minus 8 over 10 raised to the power of minus 5. Then we have 36 times 10 raised to the power of minus 8. If minus 5 should go up, it becomes plus 5. And that's 36 times 10 raised to the power of minus 3. Now 36 is not in standard form. You bring it to standard form. That's 3.6 times 10 raised to the power of 1 times 10 raised to the power of minus 3. You have 3.6 times 10 raised to the power of 1 plus minus 3. And that's going to give us 3.6 times 10 raised to the power of 1 minus 3. Because plus times minus is minus. So final answer is 3.6 times 10 raised to the power of minus 2. Alright, so again, remove the decimal. 1, 2, 3, 4, 5. That's 275 times 10 raised to the power of minus 5 times, we move 1, 2, 3. That's 8 times 10 raised to the power of minus 3. All over, we move 1, 2, 3, 4. That's 25 times 10 raised to the power of minus 4 times, we move 1, 2. That's 9 times 10 raised to the power of minus 2. And from here, we have 275 times 8 divided by 25 times 9 in one bracket, times we have 10 raised to the power of minus 5 times 10 raised to the power of minus 3 over 10 raised to the power of minus 4 times 10 raised to the power of minus 2. Alright, so from here, let's see if 275 can divide either 9 or 25 perfectly. Okay, so 25 can go into 75 perfectly. It gives 11. So we are left with 88 over 9 times, we have 10 raised to the power of minus 5 minus 3. We have 10 raised to the power of minus 4 minus 2. So 88 divided by 9 is going to give us 9 in 88. That's 9. 9 in 88 is 9. That's 81. Remainder 7. You put your decimal in 70. So you have 7, 7, 7, 7, 7, 7. You can use your calculator to check that. So it will keep giving you concentric 7. So we can stop with 7, 8. So times 10 raised to the power, this is minus 8 over 10 raised to the power minus 6. And if this comes up, we have 10 raised to the power of minus 8 plus 6. And that will give 9.78 times 10 raised to the power of minus 2. Alright, so the last question, we've been asked to write all those numbers in standard form. So from where this decimal is, we have 1, 2, 3. That's 9 times 10 raised to the power minus 3. Don't forget, anywhere the decimal is, you keep moving until you get to the first number. You stop immediately after the first number. So again, we have 1, 2, 3, 4, 5, 6. That's the first number. So it becomes 2.46 times 10 raised to the power of minus 6. It is negative 6 because we are moving towards the right. Now for this type, there is an invincible decimal here, so you keep moving. We move 1, 2, 3, 4, 5, 6. So that's 2.17 times 10 raised to the power of 6. You keep moving until you get to just before the first number. So again, here we have 1, 2. So that's 4.26 times 10 raised to the power of 2. And we have come to the end of all this, the solution on the practice question. Wish you guys all the best. God bless you all.